In this section, we want to look at the different characteristics of a quadratic function. So one thing that we're going to notice is by looking at the graph of the quadratic, we can notice a couple different elements. The first element that we want to look at is what we call the vertex. Okay, the vertex is going to be that point in which we are turning back around. Remember when we looked at those ideas of increase, decrease, constant, and what it meant to become a maximum or a minimum. That's what we want to discuss here. So notice that this vertex is caused by when we change from an increase to a decrease or a decrease to an increase. We talked about that change in motion is going to make us have a maximum or a minimum point. Now, in this type of a function, a quadratic function, it will always be an absolute maximum or absolute minimum. But we don't need to necessarily use the word absolute here. Okay, so the question is, well, when will it become a maximum and when will it become a minimum? If I'm looking at a graph, it's easy to tell because it would be if it's going to open up versus if it opens down. Okay, the way we're going to tell from an equation is if we have a positive or a negative out in the very front of the squared term. Okay, so you can see that here we've said if A is positive, then the parabola will open up, causing it to be a minimum. If A is negative, then the parabola will open down, causing the vertex to be a maximum. And remember, that goes back to our transformations as well, because remember when we were putting a negative in front, a negative A, it was going to reflect that function from what it originally was. It's going to reflect it over that x-axis. Okay, so we can see all of those things kind of coming together in this function. Okay, so we can determine if that vertex is a maximum versus a minimum. Another thing that we can look at is what we call the zeros. Okay, the zeros, another word for that is going to be our x-intercept. Now, remember we said an x-intercept is where we cross the x or sit on the x-axis. So a zero is indeed an x-intercept. Another thing that we could call this is the solution to the quadratic. So if we were going to solve this quadratic, set it equal to 0 and solve, right? So we looked at that in some of the last sections where we were solving by the quadratic formula, we were solving by factoring, we were solving by the square root property, right? And we were going to get those solutions. So you've noticed we can talk about the x-intercept, where does it cross the x-axis, the solution, setting the equation equal to 0 and solving, and then another word that we could call it, which we haven't looked at before, is the root. So any of these words all are going to describe where this function is on the x-axis. Okay. Now, another thing that we can determine also on here is going to be the axis of symmetry. So the axis of symmetry, sometimes we call it the AOS. The axis of symmetry is going to be the line that goes through the center, or as we can see, it's going through that vertex. Okay, it's the line in which the graph is going to reflect over. It's going to reflect from left to right or right to left. So sometimes it might be that y-axis, as we see here. Sometimes it might just be any line that's going through that vertex. Now, I say any line, it has to be the vertical line. Okay, so if I see this, line, I notice that the line is going to cross that x-axis. Okay, so our axis of symmetry is going to be an x equals type of a line. It's going to cross that x-axis. And conveniently, this x is the same as the x-axis, the same as the x value of the vertex. So when I find this vertex point here, I find that vertex point x, y. The axis of symmetry is going to be that very same x value. Same thing here. I find this vertex, x, y. The axis of symmetry would be that same exact x value. Okay, so I can easily tell this from a graph, but then the next thing would be to then also be able to identify it from an equation. So that's what we're going to look at here in just a second.